Hey guys, this is Mr. Larson here, and we are going to talk about the Pythagorean Theorem today. Okay, so I'm sure you guys learned about the Pythagorean Theorem at some point in the past, whether it was in the middle school or last year in Algebra 1, but we're going to revisit it today, refresh your memory a little bit about what exactly the Pythagorean Theorem is. Okay, so first off, we got a picture here to the right. That's my boy, Pythagoras. Okay, he's the one who this theorem is named after. Okay, so Pythagoras is the one who discovered this theorem. It doesn't mean he just made it up. Okay, Pythagoras studied triangles and figured out that he saw some patterns and things that kept happening. And so he's the one who gets credit for figuring out this theorem. So first, the Pythagorean theorem is used to find missing side lengths in a right triangle. Okay, so we want to be specific. Where do we use the Pythagorean theorem? With triangles, you guys might have remembered, but more specifically, it's used in right triangles. Okay, and I want to point out that a right triangle means that we have a triangle that has a right angle. Okay, so a triangle, I'm going to use the symbol, with a right angle. Okay, and you guys all hopefully remember a right angle means 90 degrees. Okay, so where are we going to use the Pythagorean theorem when we have a right triangle or a triangle with a 90-degree angle? Okay, the equation for the Pythagorean theorem is c squared equals a squared plus b squared. Okay, and I want to point out to you guys that c represents your hypotenuse. Okay, A and B are called legs. Okay, so C is your hypotenuse. A and B are called legs. I just want to add a couple things about each of those. The hypotenuse is always the longest side. Okay, it is also always across from the right angle. Okay, so the hypotenuse is a special side in a right triangle that is not only the longest side, it's also across from the right angle. Okay, now A and B, which are your legs, are shorter than the hypotenuse, right? If the hypotenuse is the longest, that means A and B, the legs have to be shorter. And the main thing I want to point out about the legs is it does not really matter which one you call A and which one you call B. Okay, so does not matter which is A versus which is B. Okay, so in a right triangle, you're going to have three sides. We're calling them A, B, and C. To plug into this equation here, C squared equals A squared plus B squared. A and B are your two legs. Doesn't matter which you call which, and C is your hypotenuse. All right, guys, and the easiest way to go through the Pythagorean theorem is to actually just try some examples. Okay, so for you guys to understand what I mean by the hypotenuse and the legs and how to use this equation, the easiest way to do it is to go through a couple brief examples. Okay, so first off, I want to point out this box here. We see this box in the corner of this triangle. That represents your right angle. Okay, so when you see that box, that's your 90-degree or your right angle. Okay, and that's important because we mentioned above the hypotenuse is always across from the right angle. Okay, so when I say across, I mean take that right angle And if I drew an arrow through the middle of the triangle to the other side, that's my hypotenuse. Okay, so the hypotenuse is always the longest, but in this example here, we weren't given a length for that side, but you can still tell that it's the hypotenuse because it's across from your right angle. Okay, so I'm going to call this C since it's the hypotenuse. All right, and now 8 and 6, those would be called our legs. Okay, the two sides that are not the hypotenuse are the legs. And again, it doesn't matter which one you call A and which one you call B. So I'm going to say, let's call 8A and 6B. It does not really matter which you call which. Okay, so our equation is C squared equals A squared plus B squared. C, we do not know. That's what we're going to be solving for. So I'm just going to leave that as C squared. Okay, now A we called 8. So I'm going to fill in 8 for A. So 8 squared plus B squared. Now B is 6. So that's 6 squared. Okay, our next step, we're actually going to square 8 and 6. Remember, guys, that squared means times itself. So 8 squared is 8 times 8 or 64. 6 squared is 6 times 6 or 36. Okay, we're almost there. So C squared, now we're actually going to add them, 64 and 36. Put it in your calculator. You should get 100. Okay, but we're almost done. I want to know just what is C. Right now, we have solved for C squared. Okay, so in order to go from C squared to just plain C, you have to take a square root. Okay, so just like when you have addition in algebra, you would use subtraction to undo that, or multiplication and division, which are opposites of each other, so they undo each other. Same with squared and square root. So when I have C squared, I want to get down to just plain C, take the square root of both sides, and the square root of 100 is 10. Okay, you can put that in your calculator, or you could think of a square root is like saying what number times itself is going to give me this number, and 10 times 10 is 100. Okay, so our hypotenuse here is 10. All right, one more example, guys, where in this case, I have my right angle box here, and across from the right angle is 13. Remember that across from the right angle is always the hypotenuse. So in this case, C is 13. Okay, I'll call this first leg, which is given to us with a length of 5, I'll call that one A. And now what's different about this example is that we're missing B, okay, or we're missing one of the legs instead of the example where we were missing the hypotenuse. Okay, so the difference between these two examples, example 1, you were given both legs, A and B, and you solved for the hypotenuse C. Okay, now we have C, we have one of the legs, which I'm going to call A, you could have called it B, and we have to solve for the other one. Okay, so filling in for C, 13, for A, 5, and we don't know B yet, so I'm going to leave that as B squared. Okay, 13 squared, you get 169. 5 squared, we get 25. Still just B squared. Okay, now algebraically, we want to solve for B. First, we need to subtract this 25. Okay, whatever you do to one side, you must do to the other side. That's the golden rule of algebra. Okay, and I'm left with 144 equals B squared. And again, guys, we want to know just what is B, not what is B squared. So to undo that squared, or get B squared to turn into just B, we square root both sides, and the square root of 144 would be 12. Okay, so in these two examples, notice both of them you were given 2 out of the 3 sides. You'll always need 2 of the sides in order to solve for the third. Okay, and also notice that that right angle box was shown in both pictures. You need to know for a fact that the triangle is a right triangle in order to use the Pythagorean theorem. All right, guys, that's it for today. Please make sure you copied all these notes. All right, go back through the video if you need to go back and make up any of the notes. Have a wonderful day.